today's lesson is going to be on the Pythagorean theorem. So I already drew my triangle up here, and this theorem only works with right triangles. So the only way you really only actually know that is if you see this little symbol down here in the corner, which designates the fact that it's a right triangle. And then let's just make sure we are all on the same page when it comes to vocabulary. The hypotenuse is the longest side of a right triangle. Okay, sometimes books will also say it's the length or the side opposite the 90-degree angle. Okay, we need to all be able to agree that that's the hypotenuse of this triangle. Now the formula is pretty straightforward. It's a squared plus b squared equals c squared. And C always has to be the hypotenuse, okay? It doesn't matter what those are, I'll just label them A, B, and C. So now we have our sides, and I know this guy's kind of big, but I really wanted to make sure that you understand that this guy is really important because this is always out there out by itself. And so from here, we can solve the Pythagorean theorem by inserting values and then seeing what we get. Let's say A was, we'll just make up numbers here. We'll start with small numbers, okay? Well, let's say A was 3 and B is 5, okay? Let's figure out the length of this guy here, because that would be the third side. Well, we follow our formula. So let me do this, get some of this stuff out of the way. And let's plug in all these things we got here. So A is a 3, so we have 3 squared plus 5 squared equals c squared. Now again, my triangle is not drawn to scale. Usually they won't be in a book. And when we get into decimals or something, we'll figure that out in just a minute. So 3 squared is 9 plus 5 squared is 25, which equals c squared. Now at this point, if you're not up on your math facts, that's okay. Or if your math is kind of not where it needs to be, you know, use a calculator for stuff like this. Okay, take out that calculator and add, you know, if you're allowed to use a calculator, I don't see why you wouldn't do stuff like this. It's good for you to practice using mental math, but at the same time, you know, plug it in, see what you get. So this equals 34. Okay, but your answer is not what is the value of c squared. The question is what is the length of side c? And in order to reduce this or to get this into a number we can use, we got to get this down to a single unit value. So 1c equals what? Well, in order to get rid of the square root, we got to, in order to get rid of the square, we got to square root this thing. Gosh, I gave you the answer. That's awful. As a teacher, that's like the last thing you want to do, right? Because that's going to blow up the lesson. Anyways, square root, the square root of 34. You could do that a couple different ways. But let's just do it calculator style for now. The square root of 34 is 5.83 ... Okay, so we can say 5.83, and we could even do squiggly equals, which means, you know, approximately, okay, because it's not exact. Sometimes you'll get them where they're perfect squares, where this value here will work out perfectly and become a 16 or a 19 or a 45, something like that. And then there'll be other times when you'll get this, and that's really as far as you can go. You do want an actual length or a distance, and so that's why I would recommend using a calculator from here, just so that you can get an approximate value. Let me erase all this and do it a little bit different. Okay, and now the formula is never going to change. So a squared plus b squared equals c squared is always going to stay the same. And I'm going to draw my triangle a little bit farther over this way this time. And I'm going to say this side is A is, we'll say 6, B is, and C is, we'll say 10. Okay, and now we got to figure out B. Let's plug in what we got before we hit the panic button and just go, I can't do this. Let's plug in our values. because already we did it where we had a and b and we had to find c. But what if you're looking for one of these sides? Okay, let's do it. A is 6, so we have 6 squared plus, well, I don't know what that one is, so let's just leave it alone and just rewrite it as b squared. And then we have this guy, which is 10 squared. We calculate this and we get a 36 plus b squared equals 100. And then from there, we need to isolate the variable. And so this guy has got to go. Now, if you've watched my other videos, you know that this is the barrier, right? And the only way we can get this guy over to this side is by doing subtraction, right? Exactly. Okay, minus 36, minus 36. Sorry, those look like 8s or funky numbers, but that's okay. B squared equals 100 minus 36. I don't even know what that is. Actually, I do. But again, I want to encourage you, if you can use a calculator on these, then do it. 100 minus 36 is 64. Check your work, okay? Even if you want to do these in your head, depending on, you know, if you're allowed to use a calculator, then use it. And then maybe check your math based on doing it in your head. It's always good practice. So we get a 64. From there, we need to isolate the variable even farther down because we don't care about b squared as an answer, we care about b. So in order to do that, we got to square root one side, and what you do to one side, you got to do to the other. Oh, what do you know? It's a perfect square. So therefore, the square root of 64 is just 8. And so that's our final answer. And so it doesn't matter if you're given, you're always going to be given 2 of the 3 sides. And usually, if the unit is in a book, they're usually going to put that little guy in there showing you that it's a right triangle, because sometimes the pictures aren't drawn to scale, and if the triangle's drawn like that, or if it kind of looks like that, that's actually a pretty bad representation. But if it looks like that and you're not sure, they're usually going to put that little right triangle symbol in there so that you know what side is the C side or the hypotenuse side. Because without this, you really can't determine sometimes. You know, these aren't drawn to scale, they're in a book, or, you know, if the teacher draws them, it just can get a little bit tricky. But once you know the opposite side of the right triangle or the 90-degree angle, then you're able to work with this. And so it doesn't matter if we didn't know if we didn't know A, then we would work through it the same way. Let's do one just to kind of wrap up this lesson. And from here, if you want to, you know, try this one on your own, you know, I highly recommend that. Always do these things. I'd rather see you do them and fail at it and learn from your mistakes, because that's really how you're going to get this stuff down. We'll say A equals, I don't know. We'll say B equals 14 and C equals 25. How about that? Let's rewrite our formula. I always do, just because I think that it really helps you keep everything in alignment. So we have a squared plus b squared equals c squared. Let's plug in some values. I don't know a, so I'll just rewrite it as a squared. I have 14 squared and 25 squared. Awesome. These numbers are getting kind of big, and that's going to happen as you move into these types of problems. That's okay. Hopefully you're not being given numbers this big and not being asked, you know, be able to use a calculator, just because that's just kind of messed up. The numbers are big. The purpose of the lesson is not how can you know 14 squared? The lesson is, do you know what to do with these numbers? So that gives you a squared plus 196, and 25 squared is 625. So again, the numbers are getting really big. This is my barrier, so if it helps you to rewrite that as so, then I would say do it, right? Remind yourself, this is a plus 96, so I need to minus 196, sorry. I need to subtract the 196. So what you do to one side, you gotta do to the other. And again, I encourage you to, as I write this problem down, pause this video, try the problem on your own, then come back and see if you got it right or not. Take a look at my steps and see if I did the same thing you did. Let's see here, a squared equals some big number minus another big number. 625 minus 196 is 429. I doubt that's a perfect square, but we'll see. And then from here, hopefully you're starting to see the same thing is happening on all of them. You square root one side and you square root the other. So A equals, I don't know, that's just a big number. 429, 20.7, blah, dot, 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 and it just keeps going. So I'll just say 20.7, and I'm gonna change my equal sign to a squiggly equal, which means that it's approximate, not an exact value, because there are a bunch of numbers back there, but we don't need them. So depending on what you're given, A, B, and C, you're always gonna be given 2. And the other key part of this is you need to just make sure you always know where the right angle is and what side is the hypotenuse. Because from there, you know what to plug in the right part of the equation. Thanks for watching.